Hi, my name is Maria and today I will show you how to obtain state space description in Matlab, which is quite useful if you want to check if your result is correct. So let's start by looking at some dynamic objects. The first one is proportional. So we are given its differential equation, which is equal to that, and its transfer function, which was obtained by using Laplace transform. But today I will not show you how to obtain this transfer function using Laplace, but I will just show you how to obtain state space description in Matlab. So let's just remember that its transfer function is equal to g of s is equal to k. So moving on to Matlab, here I have already wrote it. So I set values of k to be equal to 8, and here I'm using built-in function Matlab, which is transfer function to state space, which use numerator here and denominator here of transfer function. So as we remember, our transfer function was equal just to k, so it's quite obvious that the k here in the denominator will be k, and the denominator will be equal to 1 because k over 1 is equal to k. So let's run it and see the results. We can see the results here in a workspace, and we can see that matrices A, B, C are null, and D is equal to 8. Okay, so let's just delete that one and move on to another object, which is integrational. Once again, we have its differential equation and transfer function, which this time is equal to k over s. In Matlab, this function will look like it. So in numerator we have k, and denominator we have 1 and 0. This is matrix, by the way. So y1 over 0, as you can remember, our transfer function is equal to k over s. So if you have here s to the power of 1, so we have two numbers here. If you would have s to the power of 2, we would have 3 numbers. S to the power of 3, we would have 4 numbers, etc., etc. So this sets our s, and this will just be like plus 0. So it's k over s. And let's run it, and we can see the values of our matrices right here. Okay, the next object is inertial object of the first order. We once again are given its differential equation and its transfer function, which this time is equal to k over 1 plus st, or just st plus 1. It doesn't matter really. And in Matlab, this one will look like this. We set values of a to be equal to k to be equal to 8, value of t equal to 9, because we have t here, and numerator is once again k, and in denominator we have t and 1, because in denominator we had ts plus 1. So as we can remember from previous example, it's just s, so it's just s, so s times t plus 1. So let's run it, and we have those values. Okay, so our last example will be oscillating objects. This one is the hardest to implement, but not really. We have here its transfer function, which is k times omega to the power of 2, sigma to the power of 2 plus 2 of omega and sigma, etc., etc. So here we have its transfer function. Let's just uncomment this. So we just set values of k, omega and sigma, and once again we just put the nominator here and the denominator here. Here are spaces, this is free space, so it's 1, which here will be equal to, as you can remember, s to the power of 2. Here will be 2 times sigma times s, and here will be just plus omega to the power of 2. And let's run it. And this is our result. If you want to see the whole matrix in its way, we can just click here and we can see the value of matrix A, and it goes to all of that. So that's it. Thank you for your attention.